In previous lecture we had discussed about magnetic circuit. Magnetic circuit means a path followed by magnetic flux. So today we are discuss about definitions concerning magnetic circuit. So your first definition is magnetomotive force, or short form is MMF. It tends to drive flux through a magnetic circuit, or it produces the magnetization in the magnetic circuit, or we can say that MMF is equal to the work done in joules in carrying a unit magnetic pole once through the entire magnetic circuit. Or we can say that in electric circuit, as potential drop between any two points is measured by the work done in carrying a unit charge from one point to another. Unit of magnetomotive force is ampere turn, that is represented by AT. So your second definition is ampere turns. AT means it is the unit of MMF, it is the unit of magnetomotive force, and it is given by product of number of turns of a magnetic circuit and the current in amperes in those turns. Next definition is reluctance. Reluctance, it is represented by S, and it is the name given to the property of a magnetic or material which opposes the creation of magnetic flux in it. It means we can understand by the resistance in the electric circuit. It is the analogy between electric circuit and magnetic circuit. In magnetic circuit we have reluctance, and in electric circuit we have resistance. Just like resistance opposes the current in electric circuit, similarly reluctance opposes the flux in the magnetic circuit. So it is the name given to the property of a material which opposes the creation of magnetic flux in it. It measures the oppositions offered to the passage of magnetic flux through a material. Reluctance is represented by S. S is equals to L upon mu A, or L upon mu naught mu r A, where L is the length of magnetic path, mu naught is permeability of free space, mu r is relative permeability, and A is cross-sectional area. The unit of reluctance is ampere turn per Weber. Next definition is permeance. Permeance means it is reciprocal of reluctance, or with which magnetic flux is developed. It is analogous to the conductance in the electric circuit. So S permeance is equals to 1 upon S, or in electric circuit G is equals to 1 upon R. Your next definition is reluctivity. It is a specific reluctance, or in electric circuit it is resistivity, which is a specific resistance. So these are the definitions related to the magnetic circuit. Your next topic is comparison between magnetic and electric circuit, or analogy between magnetic and electric circuit. So here we have magnetic circuit and here we have electric circuit. So first is in magnetic circuit we have flux. You know very well, flux is represented by phi. So flux is equals to MMF upon reluctance. Similarly, in electric circuit, current is equals to EMF upon resistance. You know very well, flux means phi is equals to MMF means Ni, reluctance means S. So we get phi is equals to Ni upon S. In electric circuit, current means I, EMF means electromotive force. So I is equals to V upon R. Next is mmf, means magnetomotive force. Unit of magnetomotive force is ampere turn, that is represented by AT. In electric circuit we have EMF. EMF means electromotive force. It is measures in volts. Next is flux. In magnetic circuit, flux represented by phi, unit of flux is Weber. So similarly in electric circuit we have current represented by I, and unit of current is ampere. Next is flux density. Flux density is represented by B. Unit of flux density is Weber per meter square. So in electric circuit we have current density, that is represented by J, and unit of current density is A, means ampere per meter square. In magnetic circuit we have reluctance. Reluctance that opposes the flux. Reluctance is represented by S. S is equals to L upon mu naught mu r A. L is the length of magnetic path. Mu naught is permeability of free space. Mu r is relative permeability, and A is cross sectional area. So similarly in electric circuit we have resistance. Resistance opposes the current, represented by R. R is equals to rho L upon A. In magnetic circuit we have permeance. Permeance you know very well. Permeance means it is the reciprocal of reluctance. Permeance is equals to 1 upon reluctance. So in electric circuit we have conductance. Conductance is represented by G is equals to 1 upon resistance, means G is equals to 1 upon R. In magnetic circuit we have reactivity. So in electric circuit we have resistivity. Next is permeability. Permeability is equals to 1 upon reactivity, or permeability is the reciprocal of reactivity. Here in electric circuit we have conductivity is equals to 1 upon resistivity. So now in the last we can say that total MMF is equals to summation of phi S1 plus phi S2 plus phi S3 and so on. So in electric circuit we have total EMF is equals to, you know very well, V equals to IR. So IR1 plus IR2 plus IR3 and so on. So this is the analogy between magnetic circuit and electric circuit. In next lecture we will discuss about BH curve or magnetic hysteresis loop.